Hello everyone, this is class 6th physics, chapter number 4, force. So what is force basically? Force is that if any object is at the rest or in the motion, in the state of rest or in the state of motion, we can apply force to make the object which is at rest in the motion or to stop the moving object. Now what is the state of rest and what is the state of motion here? In our surrounding there are so many things which are keeping at the one place, which are not moving by themselves. For example, any desk, car parked. So these are the stationary items which are staying there unless we are applying any external force. So that is said to be the state of the rest. Now what is the state of motion? Like the vehicles are moving, it is in the state of motion. In which state it is? It is in the motion state. Now a body can be in the state of rest or in the state of motion, and it cannot change by its own unless we are not applying any external force. As we apply any external force, the body can change its state. For example, if a chair doesn't move unless we push or pull it. Yes, it is right. If we are not moving, applying the pull or push on any chair, it is not able to move. Similarly, if we are taking the example of the bullock cart here, that is having the circular wheels on it, so it is rolling down a slope. Slope means this is the slope. Just assume like a highway. The bullock cart is moving down. It is rolling. It is in the state of motion unless we are applying any external force. So to make it stop, you need to pull or push it. That the thing that we are using, the force, it is known as the force, which is called the push or pull. Now, what are the effects of force? In this chapter, we will study the 5 major effects of the force. So let's deal with the first one. Firstly, the force can change the state of motion of a body, and it can also do the other things. Now what are the other things? What are the other effects a body can experience with the force that we need to study here? First is, force can cause motion. How motion? If anything, any toy, any chair, table, anything is at the rest position, means it is stationary. Rest means it is stationary. Then after applying force, the force can cause what? Force will cause the motion to that body. For example, here in this picture, you can see a toy train, a toy engine is there, right? If we are applying the force from the back side, we are pushing it, then it will start moving, right? Now one main thing to be noted here is that we are applying force to other side from us. Like the person is here and it is applying force to that side. So this arrowhead is showing the direction of the applied force. As this applied force is to that side, engine will start moving to same that side. It means mostly the direction of force and the direction of motion is same. This is that the force can cause motion. How it can cause motion? With example it is clear, I hope. So let's read it now. A body at the state of rest may start moving when a force is applied on it. Just like in this engine here also. So you can see when you push a chair or pull open a drawer, pick up a box, these are the forms of forces that we are applying. We are pushing the chair. We are applying the force on it. Just like we are pushing this, we are pushing the chair. The chair will come in the motion. We are pulling the drawer to ourselves. Means we are opening it or picking up the box, applying force to upward. So these are the cases, examples you can say, where we are applying the force and the force is causing the motion. One more example is here that I already explained. What is it? Here is one figure given. A child is pushing the toy engine from the left side and the engine is moving in that direction. In the direction the child is pushing it, in the same direction the engine is moving. It means we show that the force by an arrow, that I already said, means the arrowhead points the direction of the force. Arrowhead what points? It points the direction of the force. Clear it is? The next second effect of the force is force can increase the speed. How force can increase speed now? If any ball is moving, we are hitting it or kick it again in the same direction, the speed of the ball will increase. What will happen? The speed of the ball will increase. This is this one example. You can see, if you kick a ball in the direction in which it is moving, the speed will increase. Just don't look according to the book part. Think commonly what is happening if any football is rolling in any direction. Assume it is moving in the north direction. You are kicking it again into the north. Then the object will also speed up in the same north direction. Okay. Now, the speed of body can increase how when the force act on it in the same direction, in the direction in which the body is moving. One other example is here, like if you are on the swing and your friend is pushing the swing in the same direction in which it is moving already. So the swing will move faster. This is very common. We already all mostly experienced it. The next is, you are cycling and the wind is pushing you, means it is a windy day and the wind is pushing. Now if the wind is blowing from the back side, from behind, then you will speed up, the cycle will speed up, right? So these are the two effects. Now the third one is, force can decrease the speed. How force can decrease the speed? If we apply the force in the opposite direction to which the object is actually moving. How? If a ball is moving to this side and we are applying force from the opposite, it will decrease the speed of it. Right? Now, if a body is moving in the particular direction and you apply the force in the opposite direction, then the speed of the body will decrease. What is the example of it? For example, you are on the swing, same example, and your friend pulls it in the direction opposite to the motion. So what will happen? The swing will slow down, or ultimately even it can stop also. Right? Now, we often apply the force to stop the moving objects, it means. Not only to decrease the speed, for decreasing also, but to stop the moving objects also. What is the other example of it? Like in the fields, in the different games, the fielders and goalkeepers. What is the work of the fielders and the goalkeepers? They are stopping the other opponent's team, their balls. Right? Means they are applying the opposite force to decrease the speed of it, to ultimately stop them. That's why. So the fielders and the goalkeepers, what they are doing, they are the examples, they apply the force to stop the ball. And the brakes push against the wheels to stop the motion. That is the example for in the case of the cycle. When we are applying the brakes, it push the wheel against the motion to stop it. That's why. So it means force can decrease the speed also. Just take the common example into your mind, that is the ball is moving into certain direction and we are trying to stop it or decrease the speed from the opposite side by applying the force. It means the speed will decrease or ultimately the ball can stop also. Clear? Then the next is, force can change the direction of motion. Now how? Look at this picture. Firstly understand, then we will read the concept from here. There is a ball. When we are using any cricket ball, what we are bouncing it, just assume, we are bouncing it from up to down. It again goes back, coming down from a certain height, right? Just assume I am just throwing the ball into the air. It is moving up, then I'm taking the hand at the head of the ball. What will happen then? This hand will apply a certain force on the ball which was moving actually upside, and the ball will immediately change the direction, will start moving downside first. So as it started moving downside, it means the direction of the motion changed by the force that we applied. Okay, now read it. Sometimes a force acting on the moving body changes its direction of motion. For example, when a ball bounces back from the floor, two cases we can take. A ball is, we are throwing it to upside, or we are throwing it down, ball is going back, bouncing back to the floor, from the floor to the upper side. Then you hit it with your hand. The force you apply changes the direction of motion from the upward to the downwards. This is the case. The next fifth one and the last one is force can change shape and size. One of the very common example you can take here, that is of clay. When we are playing with the clay, we are making the different objects, trying to make the different shapes of it. Because the clay is soft, so we can apply the force to change the shape and size of the clay. Size, how? We can make the any taller toy, small toy. We can change the shape of it. So these are the different things. The other example is when we are pushing a head down on the soft pillow, the shape of the pillow changes. It means the force can change the shape and the size. This is also an example to show that we are applying actually the force with the head. We are pushing the pillow downside. That's why the shape of the pillow changes. Or when we press or pull the door, its shape and size also then change. Rubber bands also, length will increase if we pull it, if we just stretch it from both sides. When an archer pulls the string of bow, the shape of the wooden frame and the string changes. What is the bow now? Tir kaman, this one thing. There is a string here. When an archer is stretching this string, the shape of this wooden frame changes and the stretch and the string's length also actually changes. That is because of the applied force. The shape and size means the things are actually changing here also because of the force applied on the string. So force can change the shape and size of the body. It is clear from these examples now. Next one. Now we have discussed the effects of force also. How the force is acting on the different bodies, on the different states, on the state of rest, on the state of motion. So we are going to define the force now. What is force? Force is something that can bring about a change in the state of rest or in the state of motion of the body, or it can even change the shape or size of the body. Understood? Next is, what are the unit of force? The unit of force is firstly a physical quantity and we can measure it. What are the physical quantities? We have done in the last chapter. The physical quantities are that which we can measure. Right? Now, the SI unit of force is Newton and it is having symbol capital N. Note here it is capital N, not the small one. Now, what is 1 Newton? 1 Newton is the approximately force that you would apply to lift the object of mass 100 gram. Means 100 gram object, if we want to lift up, we need to apply the 1 Newton force. So similarly here, if I want to lift the 1 kg, because we know 1 kg equals to 1000 gram it is. So to lift up the 1 kg of weight, we need to apply how much force? 10 Newton, and with the capital. Because Newton is the this N is the symbol or the unit behind the name of the scientist. That's why we are using the symbol as the capital and writing the unit in the small alphabets. Okay. Now there is the contact force. Two types of forces are there. One is the contact force. Second is the non-contact force. The non-contact force is not in your syllabus. So we will discuss in depth, in detail only about the contact forces. Now, what are the contact forces? As the name is clarifying everything, contact means the force which are applied on the certain body by coming in touch, in contact with the other one. Means the forces that the two bodies in contact applying on each other are known as the contact forces. For example, we apply the contact force when we push or pull the things or we lift up the things, right? When we push the chair, when we pull the drawer. So when we are pulling any object by touching it, so that are the examples of the contact forces. Similarly, the contact force also act when the bullock is pulling the cart. Elephant breaks the branch of the tree with the trunk. It is applying the force with the trunk on the branch of the tree to break it. So that is the example of the contact force. When we sit on the chair, lie on a bed, a weight doing what? A weight is pressing it down, means applying the force downwards. That is also the example of the contact force. Okay. The next thing is now, sometimes when we are applying the contact force, even without touching the things directly, we wanted to apply the force. What is there? The thing is actually contact force is working there on any body. Just assume this example firstly, then we will read it. Okay. Here is a car, a toy car is here. We are attaching a string, or just assume a thread, to this toy car and taking the other end of the thread into our hand. We are applying the force on this thread, on this string, and pulling it or pushing it, means here pulling is applied. When we are pulling it, this string apply the force on the toy starts moving ultimately with the string, with their hand, right? So it means sometimes we are applying the contact force but without touching the object directly. See here, the person is not touching the toy car directly, but here also the contact force is working. How? Because the string is pulled with the hand and this toy car with the string. So the example is, we attach the string to the toy car and pull the string to make the car move. We apply the force on the string applies on the car. So this type of contact force is applied by the string, wire and the thin rod is known as the tension. What is the name of this force? This is known as the tension applied, because we are using the thin string, or we can say wire, rod or thread, whatever. That is the case of the tension here. Now the tension acts along the rope. How the tension is acting? But this is clear, I hope. What is the tension? Tension is also a kind of the force. And what is known as tension actually? When we are using any string, any wire, any thin rod to apply the force, then in that case it is known as the tension. The force is that in that case is known as the tension. The tension acts on the rope from, just assume when we are taking the water from the well, the bucket is hanging with it. On that rope also the tension is acting. The tension acts along the rope when with which a bucket hangs in the well, or the wire from the lamp hangs. That also, the rope that is pulled by the two teams in tug of war, on that rope also the tension is acting. Clear? However, all the forces are not the contact forces. As I said you, there are the two types of forces. One are the contact forces, the second are the non-contact forces. The non-contact forces are not in your syllabus. So, the example of the non-contact force is there. One example, just to show that the all forces are not the contact forces, that's why. It is when the leaf is falling from the tree or moving down towards the earth. What is happening? This also acts as a pull, but even the leaf is not in the contact with the earth. So there are the such forces also existing between the two bodies which are in the not in the contact. So these kind of forces, but they are not in the syllabus. That is for the non-contact forces. So this is the example of it. The leaf is falling down from the tree and just going towards the earth. That is no any contact between it, between the earth and the leaf, but still any kind of force is acting there. That is the non-contact force. Next is the friction. What is friction? Very, very important topic, concept to understand. But firstly, focus on the common concept of the friction. We are taking one example here, that is of the coin. We are just flicking the coin, tossing the coin gradually on any table. What we will notice, as the coin will come to the surface of the table, obviously it stop moving, it come to the state of the rest, means but there are some of the forces which are acting opposite to the motion of it to decrease the speed of the coin, right? To decrease the speed of the coin means there must be any force which is acting in the direction opposite to the coin. That's why the speed is decreasing. These things are clear. But what we are taking, we are flicking the coin and gradually what we are noticing, that is slow down and stop on the surface of the table. It means there is any necessary force is obviously necessary to change the state of the motion of the body. It means some force must be acting there. And what is the force that which decreases down the speed? That is the opposite force, which is acting oppositely to the motion of the coin. And this force is the force of the friction. Okay, or simply friction also we can say. It acts where the surface of the coin and the table are in contact, and the same force stop a rolling ball or your bicycle once you stop paddling. What is the meaning of this now? The example of coin is, I hope, clear. We are tossing the coin. The coin just stop on the surface of the table. Why it is? Because the speed is going to decrease. How? Because of the opposite force that is acting in the atmosphere also. That is the force of friction actually. Simple friction also we can say. Two other examples are given. Any rolling ball is there. Bicycle is there. Bicycle we are paddling. When we stop paddling, it will stop down because of the frictional force. Okay. One other example also we want to take here. That is, we know the simple force is acting when any body is at the state of rest or in the state of motion. Then the force is acting. Tension is acting when we are taking the string, any wire, then. Friction is acting when the body is even moving or in the state of rest, then also. Now this is the case when the object was moving. The coin was moving, rolling ball, bicycle was going on. So that are the cases of the motion. Now in this activity we are going to take one case in which the things are stationary and we want to show that the friction is acting on it. Okay, listen the example carefully. It is important to understand. We are having the two paper bags, means cover नहीं होता जो book का, any book or notebook, but not the hard one. We are taking the two paper bags of any books. Okay, then what we are taking, the meaning of interlace is like we are having the one paper of one book. This is the book A, and just let this book be the book B. Okay, obviously this book also contains some of the pages, this book also contains some of the pages. What is the matter we are doing here? We are taking the one page of this book, starting from the back side of paperback of A, we are overlapping with the paperback of B. Paperback means the cover of the book. Okay, then we are taking the first page of this A book, overlapping it with the second page of the B book. फिर again same, next page of the A book, covering it with the completely with the B book page, last from the last. Then similarly, like we are placing the pages of the books one over the other, one over the another, turn by turn from A to B, then A, B, A, B. Then what will happen? The both books will overlap with each other. What will happen then? The two books will look like the one. Then what we need to do? We need to take the two books out. Try to pull the books apart by pulling the spines, by pulling this spine of the book. Okay, then you will find it very difficult to separate the both books. Why? Because of the frictional force is acting on them. That is the force by adding up the all small forces, it becomes the great force, which is because of the pages are sliding over one another. That's why. It means the frictional force is acting even on the stationary things also. Pages are not moving, but they have tendency to do. That's why. Now it means from this above activity or example, it is very clear that the two surfaces are moving over each other. Not only then the friction is applied, but also when they have the tendency to move over one another, over each other. Okay, so the direction of force of the friction is opposite to the direction of motion of the tendency. Okay, this is also a very important line. What is it? Any object or any person is moving to this side, the frictional force is always acting to the opposite of it. Okay, in the starting case, what we have done, I said that force is we are applying to this direction, object is also moving to this direction, but the frictional force is acting to the opposite. Why? Because the frictional force is that, the define of the frictional force is that friction is the force that opposes the motion. It decreases the speed, it slows down the speed or the tendency of the motion between the two surfaces in contact with each other. That is known as the frictional force. What is the friction in general? In winters, what we are doing, we are rubbing our hands against each other. That is also the friction. By rubbing the hands against each other, that is also example of the contact force and of the friction. Okay, a kind of new energy is generated, that is the heat energy. So that case is also the case of the friction. The next is now one, but listen this activity carefully. This is the base for the other different types of the friction. Okay, what is the activity? You just need to take a heavy book or some light books and make a pile of it. Now try to push it gently, slowly. What you will find, the book will not move. The book will not move on the table just because of the frictional force. It means the frictional force is opposing the direction of the motion of the book. As you start applying some more force, some more push on the book, you will find one point when this friction will become less than the applied force. Then this book will start moving, and then you will find that the book is lighter than the earlier time. After that, when the force of friction become lesser, you can continue the pushing the book very easily to move it to the certain distance. If you want to move or slide it for the certain distance, you need to apply the force for the same time period. Okay, so this is the activity. It is showing that the applied force and the frictional force both are acting at the same time. Same example we are taking in the static friction. What is the meaning of static friction? Firstly, when two surfaces are in contact with each other and both are at the rest, then it is known as the static friction. See, this table and this book, both are in the rest position. So this is the static friction applied here. This book is stationary on the table just because of the static friction. Okay. Now, if you apply the force to push the book until the book started moving, what you will find, the book is very much heavier that you will find. As you will increase the force applied on the book will seem more heavier. Why? Because more the push you are giving, more the frictional force the book is experiencing. More the push you are giving, more the frictional force the book is experiencing. It means this is the static friction which keeps on increasing with increase in the applied force. This is the main line. This is because the static friction keeps on increasing by applied force increases. However, one point will come when the static friction cannot increase anymore. When we can't increase the force applied, that one point will come. It means when the static friction will not increase anymore, that maximum value of the static friction is known as the limiting friction. Means the value of limiting friction is the different for the different pair of surfaces. Why? Because some surfaces are smooth and some surfaces are rough. So static friction the object is experiencing which is on above that surface, it is also different. If the different static friction the objects are experiencing, the different speed is also of there. What is limiting friction? It is clear to everyone. Limiting friction is the maximum value of the static friction after which it cannot be able to increase more. Next is the kinetic friction. Kinetic friction is also known as the sliding friction. Sliding means one surface is there which is sliding over the other surface. Kinetic means the surfaces are in motion. One is there stationary we can say, and the other is sliding over it. One example is there. Same example we are taking as that of the activity. The book slides on the table. Now when it is resting on it, it is known as the static friction. When the book is sliding over the table, it is known as the kinetic friction or sliding friction. Okay, it opposes the motion. This sliding friction or the kinetic friction opposes the motion. Means the force has to be applied if the motion has to continue. If we want to continue the motion of the book, we need to apply the continuous force, because this sliding friction is also applying continuously, that's why. So this is why you need to keep the pushing if you want to the book to keep sliding, that's why. Okay, next is friction depends upon the surfaces in contact. This is a very important short reasoning question also. Why the friction depends on the surface in contact? But as I said here also, some surfaces are smooth and some are the rough surfaces. Friction depends actually on it. So we are taking some examples to clarify it. As we already said that the magnitude of the limiting friction varies for the different surfaces in contact with each other. So this is true for the static friction, limiting friction also, for the kinetic friction also, and for the sliding friction as well. It is same. Means this concept is same. Means the value of the friction is varying according to the surface. What is the activity we want to do? We are placing a book on the inclined position. One book we are placing in the inclined position. Just like here is any book. Second book we are placing like this in the inclined position. And what we are doing, we are placing a small ball or marble on the top to roll it down. You can notice that the ball will move to much distance on the floor also. If we will just do the same activity on the simple carpet or on the ground, the ball will not be able to move that much distance. Why? Because we are finding this surface is acting as a rough and this is acting as a smooth surface. That's why the distance covered by the ball is more and less, not same in both the cases. On the smooth surface, it moves much further, very much, and the ball stops after the short distance on the rough surface. This is the reason. Hope it is clear. You can see the same here in the picture form also. There is one book. Second book is slanting on it. Ball is rolling to the much distance. It means the ball moves much farther on the smooth surface because in general the force of friction is smaller for the smooth surface and it is more in the rough surface, or we can say on the smooth surface it is smaller, lesser than as compared to the rough surfaces. Okay, next is why friction is useful. There are some of the cases that show that friction is actually very much useful in our daily life because it helps in the walking and other different activities. Let's do the first one. The first one is, firstly, friction can be useful and as well as harmful us also. So firstly, what we are going to do is, friction plays the helpful role in our life. In what ways? That firstly we are going to study. The first one is, when we walk or run, we push the ground. See, we push the ground backwards. We are applying force towards that side and the friction is acting always opposite to it. It means by pushing the ground by our foot, we are able to move in a desired direction because of the friction present. Because the two surfaces when coming in contact with each other, the friction generates there, it helps to move us. So it means when you walk or run, you push the ground backwards, yes, with your foot. The tendency of the foot is to move that in that direction. The force of friction opposes this tendency and acts in the opposite direction. Yes, the force of friction is acting in the opposite direction to the direction with which we are pushing the ground with the foot. That is, in the direction in which you want to move, it will help you to move forward if you are pushing the ground towards the back side. Obviously, when we are walking, we are pushing the ground with the foot to that side and the friction is acting to the opposite side. Means friction is acting to that side to which side we want to move actually. If the force of friction between your feet and the floor is small, what will happen? We will slip, we can fall also even. So this is what happened when you slip on the highly polished floors while water and slipped on the floor. This is because of the lesser friction. The force of friction between this and this is small, that's why. The second case is the friction between the wheels of the vehicle. The surface of road allows the wheels to roll forward. Means, but if there is no any friction on the surface of the road, the friction will reduce down. Only this frictional force is helping the wheel to rolls forward. Otherwise, it can slide. The vehicles can skid, means move away without any kind of control on them, on the especially wet, muddy, oily surfaces on the roads. Okay, the next one is the brakes are applied to stop the vehicle. The force of friction between the brake shoes and the wheels slow down the wheels. How it is possible now? When we are applying the brakes, there is a kind of fluid between the near the wheels. The complete system you will study in the higher classes. What is happening there? That system is actually generating the force of friction acting in the opposite direction to which the wheel is moving, and it ultimately slows down the wheel, which stops the wheel. That's how the brakes are acting. Then the next is the friction allows us to grip an object between our fingers. For example, this pencil we can grip with our fingers because there is tendency to fall down the pencil. It can slide over from our hands, from our fingers to downside, but the friction is taking it to the upper side. It means this is the thing how we are holding the different things with the hand, with the body. It means the friction will also allow us to grip any of the object. So in general, it is very difficult to grip if the surface is very smooth, object is very smooth, such as an ice cube. It is providing the low friction, so it is very difficult to grip them. Next one is pencils can write with the help of the friction only, because of the friction only, because the lead of the pencil that is made up of the graphite, which is the form of the carbon. So when the friction is there between the lead and the pencil, lead of the pencil and the paper, what it causes, the small particles of the graphite break down and deposit on the surface of the paper. This is because of the friction between the lead of the pencil and paper. So with that friction, the particles break down on the surface of paper and we can see the simply the written writings of or on the paper. You can figure out that why it is difficult to write on the smooth surfaces such as on glass and polythene, because they are providing very lesser friction and the pencil is sliding very easily on them. It is not able to deposit their things on it, on that surface. That's why because of the lesser friction it is difficult to write on the smooth surfaces. It is difficult to write on smooth surfaces. Okay. Sixth is friction is used to smoothen the surfaces. How friction is used to smoothen the surfaces? You know what is the sandpaper? It is of the brown color, very rough surfaced paper, which is used to remove the paint also from the doors, from the walls even. You might have seen this with the carpenter also. So carpenter use this sandpaper, this rough surfaced brown colored paper, to smoothen the surface of the wood. Large the force of friction produced when it is the rough surface is rubbed on the wood wears, which is having the bumps on it. What is the meaning of this line? Just assume there is the branch of the trunk of the tree. Okay, it is having some bumps on it. These bumps are easily made plain with the help of this sandpaper, and this will show the large amount of frictional force. Why? Because this is so much rough, the surface is too much rough, and when we rub against these two things with each other, it will produce the very large amount of frictional force. The last one, seventh benefit is when the two surfaces rub against each other, the friction between them produces heat. This example also I explained earlier. When there is the winter season, we are rubbing our palms against each other and this produces the heat. This has some uses also, that we are doing it when we are feeling the cold. In the ancient time period, in the primitive mans, how they are just generating the fire, they are rubbing the pieces of stone and wood against each other. And even when we rub the matchstick with the outside paper, which is rough paper around them, it starts igniting, providing us fire. The heat produced by the friction make the chemicals on its head catch fire. That's why it is. Okay, so next is now increasing friction. How can we increase the friction? Now, whenever we are finding that the friction is helpful for us, we try to increase it for our advantage. There are three main points which we are going to discuss here about the advantages of the friction, because of which we want to increase the friction in some of the things. First is, you may have noticed that there is on the surface of the tires, there is a pattern. You can see here in this picture also, there is a pattern which is known as the treads, which improves the grip and which helps the tire not to slip on the road. Okay, that's why it is the design or a kind of pattern known as the treads on the sole, on the top of the tires. This is the sole of the shoes or of any of the footwear that we are using. You all know that there are the grooves on the surface. This is also for the same reason, to improve the grip and to reduce the tendency to slip down. That's why this is also here. Next is the pavements and the playing areas, such as the basketball courts. They are having the surfaces slightly rough to prevent the slipping of the players. Okay, next is the handle of the cricket bat has also some layers of the coarse fitting string. Yes, the handle of it, and it is having the some close fitting rubber like tube like structure is there and having fine some design on there. This is to increase the friction. This improves the grip of the person who is holding the bat. Next is what are the different problems which are caused by the friction. The first and major problem is that the friction opposes the motion. So this is a disadvantage. We need to apply the more force to move any object. If we are riding the bicycle is very much older. What will happen? Just because of the friction, we know that the number of moving parts are there in the bicycle. When the bicycle is moving, it is due to the dust and rust or due to the older bicycles, some of the parts are having rust on it. So it is very difficult to overcome that friction because we need to apply the more force. That's why, which increase the rougher surface and which increase the frictional force ultimately. Hope you can see this picture and the pattern which is written here that I explained just now. What is it? Because of the friction is opposing the motion, that's why it is a disadvantage for us. And when we want to overcome the frictional force, it become difficult for us. Why? Because of the rust and dust, the parts of the cycle become too rough if the surface of the cycle is older, very much old bicycle we are using, right? If we are using very much old bicycle, the rust and dust of it make the our efforts more, right? It needs our more efforts to overcome that frictional force. This is because of the rough parts only, and that is the reason that's why it requires a greater effort to ride an old and rusty bicycle. The next is the shutters, door hinges. Door hinges means like this is the door. From here the doors are joined. These are known as the door hinges. The door hinges and the sliding windows and the other moving parts, it becomes difficult to use them when the friction increases because of the rusting on, because of any other reason. That's why it becomes difficult to use. Why? Because friction increases with these kind of things, with the rusting or any other reason. The friction causes heating in all machines with the moving parts. As I said earlier, when we are moving our hands, rubbing our hands against each other, what it produces in the cold weather, it produces heat to us. Same here also, friction causes the heating in the machines while moving the moving parts. So this can ruin the machine unless the proper precautions are taken. So this is the very big problem in most of the machines. When we are using it for the long hours, it just can deform the machine. Okay, next is over a period of time, the moving parts of machine, tire and soles, what happened to them, wear out due to the friction, because friction is acting on the soles also, on the tires also. So the design goes away, the wear out will happen there. Even our teeth were also wear down due to the friction. Interestingly, one other fact is also there. The rats are doing and the other animals are doing the just cutting of the other clothes and other things, gnawing it. Why? Just to prevent that their teeth will not grow too long. That's why. It means there also friction is produced, because of which their teeth are trimmed out of the rats. That's why they are doing so. Now, what are the different ways to reduce the friction? 4 points we will do mainly here. The points to reduce friction. Wherever the friction causes problems, we try to reduce it. One thing is that we needs to increase the friction. Second is what are the problems with it. Second is if we wanted to increase the friction because we are finding some of the advantages due to them. Secondly, when we are finding some problems with them, because of these problems we want to reduce the friction now. Whenever friction causes the problems, we try to reduce it. For example, we try to reduce the friction in machines to make them run smoothly and with the less effort. So reducing friction can also increase the life of the machine, because it will give the less heating to it and the less efforts we need to apply. Smoothly run it will be there, right? So commonly we use the lubricants, means, or we can paint the machines to run them smoothly. The most common method to reduce the friction is the moving parts of the machine is to apply the machine oil, grease, and these materials are known as the lubricants. If your cycle is cleaned and oiled regularly, it will run very smoothly and last long, and you have to apply the very less effort, right? Second is the sliding parts of machine are made as smooth as possible to reduce the friction. The sliding parts, or which we can say the parts which are moving more, that must be made with a smooth surface to reduce the possibility of the friction. It is difficult to push a table from one end of a room to the other end, but if the table has the wheels, it jobs a lot easier. The job will become a lot easier. Why? Because the friction is less, right? When the something rolls over the surface, then when it slides over the surface, we can say that the rolling friction is lesser than the sliding friction. But what is the case here? We are having simple table. We are having the table with the circular wheels on it. The rolling friction is very less as compared to the sliding friction. Why? Because it is taking the lesser surface in contact with each other, so providing the lesser friction. Now this is the case in which you can remember here, the rolling friction is very less, limiting friction is very more, sliding friction is in between in comparison of their strength. Okay, so this is why the trolleys, computers and the TV tables and the pieces of the luggage are provided with the wheels on them. You can see the trolleys, and these are the ball bearings on the different parts of the machines, or on the cycle parts also these are present. So these are for making the friction less, to reduce the friction. This is also why smooth metal balls and the ball bearings are used to reduce the friction in the machines which rotate with the rotating parts. Where the parts are rotating more, there they are trying to use the ball bearings, this one thing. Okay. Nextly, these balls are usually arranged between two metal rings, and the rings rotate with very little friction. These rings are rotating with very little friction because the balls between them roll on. Because of the rolling of these balls, it provides very lesser friction. The ball bearings are used in the cycles, in the fans, cars and machines. This can come as the internal question also. Okay, but I hope this is clear. One of the other example is there to show that the rolling friction is how lesser as compared to the sliding friction. If you are taking the metal cap of a pickle or jam bottle, this is the metal cap of the jam bottle, assume. Okay, we are just moving it on the flat surface. We are just trying to spin it. Then place some marbles. We are trying to spin it. It is not spinning that much easily. We are placing some marbles below it that are circular in shape. You can find that this time it will spin more easily and for the much longer time. This is how the ball bearings are working in the machines. Okay, the last one point is also very important. Here you can see the picture of the aeroplanes and the boats. You can see that the body difference in these. This is very much slanting, and you can say pinpointed body is there. Here also the bodies of the of this shape, right, which is having the narrow edges, right? And the aeroplanes and the boats are the streamlined shapes to reduce the resistance offered by air and water. But just like we took the example of the coin tossed and it stops on the table, when it stopped on the table, what it experienced actually, the frictional force? It experienced the frictional force from the air. The same is here in these two cases. Here the airplane is experiencing the force, resistance, opposite frictional force offered by the air. In this boat, it is experiencing offered by the water. So when an object moves through the air, it faces the air resistance. Resistance means opposition. The resistance to motion offered by the air is very similar to the frictional force. This is commonly referred as the air resistance. Liquids also offer the some resistances, which is such resistance. To reduce the resistance offered by the air and water, the aeroplanes, cars and boats have the shaped in the particular way that is known as the streamlined bodies. So the nature streamlines the bodies of the birds and fishes also, just to make them feel free and easy to move in the air, birds in the air and fishes in the water. The same streamlined structure we are just doing with the aeroplanes and with the boats also. So with this, the chapter's explanation is completed. After that, you can read the points to remember the main points of the chapter. If this video is little bit even helpful for you, then please like, share and subscribe to my channel. Meet you soon with the next video. Till then, take care, keep doing hard work with consistency. All the very best.